So we came to know that A dot B, what is the A dot B formula? What is A dot B formula? A dot B formula is AB cos theta. Okay. And
AB cos theta.
What? Cos theta formula is?
Oh, A dot B by
A dot
A dot B by mod A, mod B. A
mod
dot B divided by modulus of A, modulus of B. Okay. Now, and we have commutative property also. What is the meaning of that? A dot B equal to B dot A.
B dot A.
Commutative property is A dot B equal to B dot A. And distributive property?
A dot B plus C is equal to
A dot B plus A.
B plus.
Very good. A dot B plus C equal to A dot B plus A dot C. Now, what is B? B on A. What is it called? What is
projection of B.
very good. Projection of, suppose this is vector B and this is vector A. This is what? This line is said to be the projection of B on A. Is that clear? And theta is the angle between the two vectors. So that is why. So when we resolve the component, let's suppose this is vector B and this is theta. So we have two components, B cos theta and B sin theta. That's good now. We have two components, B cos theta and B sin theta. Here, B cos theta is said to be the horizontal component and B sin theta is said to be the vertical component. Now, what is the statement of work energy theorem?
The change in kinetic energy of a particle is equal to the work done on it by the net force.
Very good. The change in kinetic energy of a particle is equal to the work done on it by the net force. Okay. So what we have done? So there is a body whose mass is m, initial velocity is u, final velocity is v, displacement is s. Now, when this is the equation of v square minus u square is, that's the equation of motion, v square minus u square equal to 2s. Multiply half m on both the sides. Half mv square minus half mu square is equal to half m into 2as. 2 goes away. This is final kinetic energy minus initial kinetic energy is equal to force into displacement. Force into displacement is work done. Is that clear? Is it clear?
Yes, sir.
Now,
Yes, sir.
now we will start with the work. Okay, definition of work. Then positive work done, negative work done, zero work done, and some standard values of energy work done. And then we can do a small numerical also. Now, so did you solve this question? F and I, all of you. F and D. Did you solve this question, all of you? Girls. Yes or no?
Yes.
Yes, sir.
Huh? Okay. See, once again here, I'll just do that one. Here we need to find out what is that F dot D we need to find out, and also we need to find out the angle theta. So what we are doing, F dot D equal to 3i cap plus 4j cap minus k cap minus I cap plus 3j cap minus 4k cap. Okay, so it is equal to how much? I into I will become 1. So 3 into minus 1 plus 4 into 3 plus minus 1 into minus 4. Okay. This is the value. So what we are going to do now, multiply. So we are going to multiply only I with I, J with J, K with K. We are not going to multiply I with J. Why? Because I dot J will become
0.
0. And J dot K also will become, I dot K also will become
0.
0. That is the reason we are not taking J dot K, I dot K, I dot J on all. Okay. So only we multiply with the similar terms. So minus 3 plus 12 plus 4. So how much it is now? 16 minus 3 will become
13.
13 joules. Now modulus of F is equal to how much? Under root of 3 square plus 4 square plus minus 1 square. So that is equal to how much? 9 plus 16 plus 1. So that is equal to root 26. Similarly, root D, modulus of D equal to how much? So minus 1 square plus 3 square plus minus 4 square, which is equal to under root of 1 plus 9 plus 16. That is again equal to root 26. That is again equal to root 26. Now we will find out what is the angle. Okay, how much is the angle now? Now, cos theta formula is f dot d divided by mod f mod d. Okay, so cos theta equal to f dot d equal to how much? 13 divided by root 26. So cos theta equal to 13 by 26. Cos theta equal to 1 by 2. Theta equal to cos inverse of 1 by 2. Theta equal to, when do we get 1 by 2? 60 degrees. Okay, or we can also write pi by 3. Is it clear? This is the angle between the
Yes, sir.
Yes, sir.
two vectors. Okay, please do copy this one. If you are in any doubt, please ask me. So here work is, like suppose this is a body whose mass is m, and a force is applied like this. Maybe there is some bag or something, or maybe some box. There is a box on the floor, and and it is connected with a rope or something, and we are pulling it. So it is making this rope is making an angle theta with the horizontal. Okay, this rope is making an angle theta with the horizontal, and d is the distance between the, or d is the distance or the displacement. Okay, so how do we define that? So the work done by the force is, the work done by the force is defined to be the product of component of the force in the direction of the displacement, and the magnitude of the displacement. So what he says, the work done by the force is defined to be the product of component of the force in the direction of the displacement and the magnitude of the displacement. Means what? If you look at the component, suppose this is the force, this is force, and it has two components. This is theta. What is this component called? This component. What is this component called?
F cos theta.
F cos theta. What is it known as? F cos theta. What it is known as?
Horizontal component.
Horizontal component. F cos theta is known as horizontal
Horizontal.
component, and F sin theta is known as
Vertical component.
vertical component. Okay, horizontal component and vertical component. Okay, so F cos theta is in the direction of the displacement. So how do we write that? W equal to F cos theta into D. So that is equal to what? F equal to W equal to F d cos theta, which is also known as W equal to F dot D. Okay, W equal to F dot D. That is dot product. Clear? F into F d cos theta, and then we write F dot D. F dot D is not final destination. Okay, a force into displacement. Is that clear? Work done is equal to force into displacement. But on work done, I haven't written the bar. Why? For F and D, I wrote bar on the top. But for W, I didn't.
Scalar quantity.
The scalar quantity.
Very good. Work done is a scalar.
Work is a-
Very good. So unit of work done is what? Unit of work done is joule. If you are writing the full name, write like this, all in small case, or Newton meter, or kg meter square per second square. These are the units. This is the unit. Okay, kg meter square per second square. So this is the unit. Okay, so and what is it? Is a scalar quantity. It's not a vector quantity. Scalar, it is a scalar quantity. What else is there after that? It's a scalar quantity. And dimensional formula is what? Its dimensional formula. Its dimensional formula is ml
ml square per t square.
ml square t power minus 2. Okay. So this is about the dimensional formula. Okay. Now, now we have a positive work done, negative work done, and zero work done. When I speak about positive work done, first case is positive work done. In positive work done, what is the meaning of that? In positive work done, theta equal to 0 degrees implies cos 0 value is 1. Theta is 0 degrees, cos 0 value is 1. So positive work done is what? If both work, the force and displacement F and D are in the same direction. So then that is known as positive work done. Okay. If force and displacement are in same direction, then it is positive work done. Okay. Then it is positive work done. Please do write this one. Then we'll go ahead. If you have any doubt, please ask me. Now here we have positive work done. Next is negative work done. So negative work done is when theta equal to 180 degrees. Implies cos 180 is minus 1. Okay, cos 180 is minus 1. So what is the formula? W equal to F dot D, which will be equal to, or FD cos theta. FD cos theta, which will be equal to minus F dot D. So in this case, what happens? If either force or displacement are in opposite direction. If they are in opposite direction, if either F or D are in opposite direction. So anyone, if it is in opposite direction, what happens? The work done is a negative work done. Next is zero work done. Zero work done. Zero work done means if either F or D is equal to 0, F or D is 0. This is one case. Or if the angle between, or we can write here, if theta equal to 90 degrees. What is cos 90 value? What is cos 90?
0.
0. Yeah. So work done will be, W will be equal to 0. Work done is 0. So what is the meaning of this? Example I will take here. A potter is taking a box. He is carrying. A potter is carrying some luggage box on his head. According to physics, he is not doing any work. It doesn't mean that you will not pay any bill money to that man. But according to physics, he is not doing any work. Why? Because weight is acting, weight W equal to mg is acting downwards. But the displacement is exactly of 90 degrees. D is in this way. Force W equal to F equal to mg is acting downwards and displacement is in 90 degrees, exactly 90 degrees. So the work done is 0 in this case. Got it? The work done is 0 in this case.
So under negative work done, you've written W equal to F dot D. You've not put the bar. It's okay if we write it that way.
We can write FD also. Okay, no problem. Or F dot D. You can write that. Minus F dot D. Okay, so therefore now, in the first, this is the first example. The second example is so a weightlifter is holding some weight on his shoulder for some time. According to physics, he is not doing any work. How come? Suppose he's lifting the weight bar and putting on his shoulder. Okay. So according to physics, he's not doing any work. Why? In this
No displacement.
Yeah. So suppose weightlifter is not doing any, like suppose he's taking 100 or we can write 50 kg bar on his shoulder. Is there any displacement in this case? Is there any displacement? Yes, Roma, no problem. So,
No.
so
No
that's
displacement.
how much? 50 kg bar he is holding. So here displacement D, that is the reason. Okay.
Yes.
Next one, third one is like rotation of the moon around the earth. Suppose this is the earth and this is the moon. It is moving around the earth. So according to physics, the moon is not doing any work. Why? The angle is again 90 degrees. Okay. Angle is 90 degrees. Is it? According to physics, he is not doing any work. Okay. Is it clear? So the rotation of the moon around the earth, rotation of the earth around the sun, rotation of the satellites around the earth, they are not doing any work according to physics. Why? Because the angle is 90 degrees. Is it clear? Now, there are some standard values that is very important. One erg. We did this before also when we were doing the first lesson. One erg is equal to how much? Anyone, do you remember this? One erg equal to 10 to the power of minus 7. And erg is what? Unit of what? Erg
Energy.
is SI unit of energy. Energy. Okay. Erg is, this is CGS unit of work done. CGS unit of energy or work done. Okay. Energy and work done are having the same units. Second one, electron volt is equal to how much? It is used in physics, chemistry. 1.6 into 10 to the power of minus 19 joules.
Minus 19
Let us
joules.
use this. Electron volt. Electron volt is a unit of in chemistry. In ionization energy, in electron affinity. Remember that.
Yes.
What is ionization energy? It is the amount
Energy to
Giant.
remove an electron.
of energy required to remove an electron from the outermost orbitals of neutral gaseous atom. How much energy is required? That is measured in terms of electron volts. Next one, 1 calorie. 1 calorie, this I will again explain in liquids while teaching thermal physics. 1 calorie equal to how much? 4.186 joules. Okay, this is again one more unit where CGS unit is greater than MKS unit. There are certain units where CGS unit value is greater than the MKS. 1 kilowatt hour. 1 kilowatt hour is the electrical value, electrical unit. That is 3.6 into 10 to the power of 6 joules. Okay, please note down these values. These are the standard values. Please do remember these values. Sometimes in examination, they won't give these values. Also useful in grade 12 also, as also useful in thermal physics. Energy. How do you define energy? Ability to do work. Ability to do work is energy. So energy is, the unit of energy is joules. Again, joules or calorie measured in kg meter square per second square. Okay. So next unit, it is a scalar quantity again. It is a scalar quantity. Energy is a scalar quantity. Now, so we will speak about mechanical energy. So if you look at mechanical energy classification, ability to do work, okay, that is mechanical energy. So in mechanical energy, we have two types of energy. One is what? Potential energy. The second one is kinetic energy. In potential energy, again, we have two types. One is GPE, one is EPE, elastic potential energy, gravitational potential energy. Elastic potential energy is what? That is equal to mgh. And elastic potential energy is half kx square. Kinetic energy is half mv square. Okay, this is the classification. Okay, what is potential energy? First, we'll discuss, write the definitions of all. Now, so, work done due to the mechanical force or the applied force is said to be mechanical energy. Next one, here we have potential energy. Potential energy. How do you define potential energy? Energy possessed by the body energy possessed by the body due to height or shape is said to be potential energy. Now suppose I'm holding a stone above the ground. If I release it, I am holding a stone above the ground. If I release it, it can do some work. Okay, that is due to the position. So in that, the first one is what? Gravitational potential energy, GPE. Gravitational potential energy. Gravitational potential energy. So what is this? Energy possessed by the body. Energy possessed by the body due to position. Energy possessed by the body due to the position is said to be gravitational potential energy. So what is that? Gravitational potential energy equal to what? mgh. Suppose there is a stone which is at a height h from the ground, whose mass is m, gravity is g. So the formula is mgh. Clear? Now the second one is elastic potential energy. That we are going to derive it now. Elastic potential energy. Elastic potential energy. So in that, energy possessed by the body, energy possessed by the body